Good morning and welcome back. Today we will be talking about the next section of Chapter 10. So continuing on area, this section is specifically dealing with shapes that are regular polygons. So if we can recall, a regular polygon is both equilateral and equiangular, meaning all the sides are congruent, all the angles are congruent. Remember, we know congruent means equal or the same. So like on this shape, it's a five-sided figure. Each side would have the same length. Each angle inside is the same. Okay, so to start off though, we're just going to establish some different parts of it. So the first thing I want to talk about is the center of each of these polygons. Okay, this should be very easy for you. We know the center. We know what that word means. So let me get rid of that. Okay, we know the center is just in the middle. Okay, very easy. Okay, now the next word, radius. Now we know when we have a circle, the radius is the distance. So if I put a circle up here, it's the distance from the center point that we just had to the edge, okay? It'll be that same concept. So let me show you. You don't necessarily need to draw this, but if I have a circle here on, oops, let me fix that. Okay, so I didn't draw it perfectly, but the circle should have gone through each of those points. I'm off a little bit. I think I'm a little low. And if that's the case, then from the middle here to the circle would go to one of those corners. It could go to that one. It could go to the right, up, left, down. Wherever it goes, it just goes to one of the corners. So for the radius of a polygon, it has to start in the center, and it goes to one of the vertices, a straight line. Okay, on all of these, I went down to the left. It could go up to the right, just to one of the vertices. Up to the left, down to the right, up to the right, whatever. Then finally, the apothem. This also starts at the center, except it goes to one of the sides and forms a right angle. So it's perpendicular, okay? So it could go down. If you want, you could also have it go left, right, up. Anyway, it just goes to one of the sides and forms a perpendicular situation, so a right angle. And the reason this is useful, it will help us to solve. So if we look at these same three shapes, once again, we have our pentagon, our octagon, and our hexagon. If we put a dot here at the center, and then the radius goes to the corner, and the apothem comes down, do you see how now we have a right angle formed? Okay, so that was our apothem, this was our radius, this was our center. We'll do it again on this one. So apothem, radius, center. And finally, our last one. Apothem, radius, and center. And the reason this is helpful is if you look up here, if we look up here, I'll talk about this first. If we think about it, if I have this center and then an apothem here, and I can form an angle there, another triangle there. If I have another apothem, another triangle is formed. Apothem, another triangle will be formed. The apothem, another triangle is formed, and then the apothem. So as you can see, we can divide each of these shapes into lots of triangles. We know the formula for a triangle, so then if we know what the apothem is and the side length, we can figure out the entire shape's area. Very simple. Okay, so in order to do that, we're going to use the perimeter because we want what all those sides are. So if we look here, this shape has a side length of 9. Perimeter, we know we add them all up. As you can see, if they're regular polygons, there's 4 sides, each of them 9. 9 times 4 gives us 36. Okay, this next one, 14.1, kind of hard to read. There's 5 sides, so we do 5 times 14.1. If you need to, open up that calculator. You can do 5 times 14.1. Let me move this so you can see it. So 70.5 is what we get for our perimeter. Okay, now number 3 and 4, we have to be careful. On this one, do you see how the 2 is staggered over here? That means this side is also 2. So if we think about it, that whole side would be a length of 4. Okay, now I have 1, 2, 3, 4, 5, 6. So 6 sides times 4 gives us 24 as our perimeter. And finally, the last one here, once again, it's staggered. So 1.2 and 1.2. That means our side length is 2.4. This one we can count 1, 2, 3, 4, 5, 6, 7, 8 sides. So 8 times 2.4. And we will get 19.2 as our answer. That's the perimeter. That does not tell us the area, but that will help us get the area. So, our formula now. Much like when we have a triangle, the area of a triangle is 1/2 base times height. If we think about it, our height, the apothem is kind of doing that same role. It's like the height. It goes from low to high of this triangle. Now, the base right here is just that chunk. But if we think of all those triangles wrapped around, the base would be the perimeter. Okay, so that's why if we do the perimeter in here and multiply it by 1/2 times the apothem times the perimeter, that will tell us the area of the whole shape. So we look here. It asks us a couple questions on number 5 here. What's the value of the apothem? Hopefully that's easy for you. Even though there's not a right angle, we can see the apothem is 6. It asks us what the perimeter is. So if there's a 10 here, 10 times 1, 2, 3, 4, 5, it'll be 50. Okay, so your next one now. It asks us to find the area down here. So 1/2 times A times P, 1/2 times 6 times 50. Half of 6 is 3. 3 times 50 will be 150. Once again, we don't have a label, so units squared. Okay, same idea on number 6. The only difference here is apothem we still know, it's 10. When we find the perimeter, okay, there's 1, 2, 3, 4, 5, 6, 7, 8 sides. You can't do 8 times 3.3 though, because remember that's only half of it. We'd have to double that first, because there's, so if we take 3.3 times 2, we get 6.6. Then we can do 6.6 times 8, and that 52.8, that is our perimeter. Okay. And at this point now we can do 1/2 times 10 times 52.8. And if we do this, we will get 264. All right. 4 shapes left. Let's find the area of the regular polygons. So same process, just doesn't prompt us as much, but we can do the same thing. So this one will be 1/2 times the apothem, 9, times our perimeter. There's 4 sides, each of length 18. 4 times 18 is 72. Okay, so 1/2 times 9 times 72. Once again, feel free to use a calculator. This will give us 324 units squared. I realized on the last one I forgot, so units squared, put that up there. Okay, we're almost done. Once again, on this next one, 1/2 times 8, now times the perimeter. Perimeter, there's 5 sides, each of 14. 5 times 14 is 70. Half of 8 is 4. 4 times 70 gives us 280 units squared. Almost done. This last one, or last row, we got 6 sides. Each of them will be of length 4, because remember 2 and 2. So our perimeter, 6 times 4 is 24. Half times the apothem, which is 3.2 here we see. So 0.5 is the same as half, times 3.2 times 24. We hit enter, we get 38.4. Okay, and we're almost done. The final one now. If we look at it, once again, 1.2, we know there's a 1.2 here, so 2.4. We have 8 sides, so take that times 8. So half times 3 times, so 8 times 2.4 will tell us our perimeter. We get 19.2, so we plug that back in. So 0.5 times 3 times 19.2. So 28.8 is what we get, and that is our final answer here. Don't forget units squared. So if you need anything, please reach out. There is an It's Learning assignment. Please get that done. Hope you guys have a great day, and definitely send me an email if you're confused or if you need help, or ask me in person if you're able to come to school. So talk to you later.